Hello, and welcome to Science Research Weekly, Season 4, Episode 4, Venti Vanilla Frozen Star to go. Get ready for asteroid analysis, precision probiotics, nifty nanolattices, dark dimensions, frozen stars, and the return of the top 20 new CRAN package blog series. This episode covers material from January 24th to January 30th. Let's get started with some research articles. First up here is abundant ammonia and nitrogen-rich soluble organic matter in samples from asteroid 10-1955 Bennu. So asteroid Bennu is a B-type asteroid with a mean diameter of almost 500 meters. And has a small risk of hitting Earth in the next few centuries just because it can come pretty close to the Earth. So spacecraft have actually landed on Bennu and recovered a sample mass of 121.6 grams, apparently the largest ever retrieved from an asteroid. It's returned to Earth, and under sterile conditions, researchers were able to analyze the chemistry of the samples and found, of course, abundant ammonia and other nitrogen compounds, including amino acids in all 5 nucleobases. So, interesting thing here. We don't often get actual asteroid components back that are sterile. So, anyways, moving along here, we have our next article: metabolic modeling for probiotic and prebiotic production to treat inflammatory disorders. So this is a perspective highlight. And researchers outline how to leverage genome-scale metabolic models to test probiotics with therapeutic potential. Precision medicine style. I believe I have, so the graphical abstract here. So you sort of start at the microbial community level. You can use this genome-scale metabolic models and also something called flux balance analysis. And you can actually design and then test probiotics to individually benefit a human patient, rather than just a broad scale try to tailor. Again, that's that precision medicine coming in, tailor the probiotic or even prebiotic for the individual. See, moving along here, we have the next research article: ultra-high specific strength by Bayesian optimization of carbon nanolattices. So researchers were able to create these nanostructures from carbon that actually, I think the real interesting line here is that they have the strength of carbon steel and the density of styrofoam. So that's really interesting here. I think some of the problems with some of the nanostructuring is that you can make them fairly strong, but then they're brittle. And so apparently they've been doing pretty good here to make these both strong, but then, of course, light. Okay. Moving along here, we've got advancing long-read nanopore genome assembly and accurate variant calling for rare disease detection. Researchers use nanopore long-read sequencing using samples from a rare disease cohort of 98 people. I think from something like 41 families. And they were better able to diagnose rare diseases and the characteristics of, I think, the genetic anomalies with this long-read sequencing compared to sort of the more standard short-read sequences. So that's shows that long-read sequencing is becoming more popular because it's becoming more accurate and affordable, is really going to help out disease detection. And okay, yeah, I mean, here's the sequencing protocol of this. So you start with the DNA extraction and all the setup here, and then they're using the prometh ion sequencing. Yeah, for those who are just listening, I'm looking at figure 1 of the article. Okay. Switching gears here, we have the article PFAS biodegradation by Labrys portucalensis F11, evidence of chain shortening and identification of metabolites of PFOS 6.2 FTS and 5.3 FTCA. So a lot of jargon in the title. What is going on here? Well, PFAS, or forever chemicals, they've been in the news a lot lately given their presence in the environment and the fact that they don't really break down, so they have longevity, aka forever. But researchers were able to use the bacteria, Labrys portucalensis, F11, and degrade several of these PFAS chemicals. So some of them were, within 200 days up to 96% removal. So helpful there to actually use a bacteria to degrade chemicals that were said to be forever chemicals, but if we can degrade them, they're not forever. All right, we're going to turn into some very interesting physics here to close out our research talk, the research article talk. We have the article Dark Dimensions with Little Strings Attached. So strings theory posits extra dimensions on the micro scale. However, some theorists working on dark matter posit what they call a dark dimension, which would be on actually the mesoscale, so a micron in size. So micron is very small conventionally, but it's apparently really huge when it comes to extra sort of curled up dimensions. So that's really interesting. I think some of obviously a lot of the physics is beyond me, so I actually have a summary also, and so you can find this in the description, the links to Advanced Science News, which breaks down this, and the title of this is A Dark Dimension Could Help Explain the Origins of Dark Energy. So that's helpful to explain that. The other interesting sort of physics-y paper is called Sourcing the Keir Geometry, which, if you're like me, probably had no idea what that meant and what the article was even about, but it turns out it's about rotating frozen stars. So that's really cool. So I had to dig more into it. So essentially, frozen stars are theoretical cosmological objects that act a lot like a black hole. They essentially mimic the observational characteristics of a black hole, but they're very different sort of inside and help deal with sort of sourcing the Keir geometry. So they make some of the observations and weird things about black holes, like singularities and event horizons, go away. And so that's what they talk about here. And I think originally there's only models for sort of static frozen stars. Now this article allows for rotating ones, which would help mimic the fact that there are rotating black holes. So really interesting here. Again, I'm going to have in the description a summary from Advanced Science News, which talks about this. So, and again, just like the first one with the dark dimensions, which sort of ties in string theory with cosmology, this one also does. Where frozen stars come from involves string theory. So, like it or hate it, there you go. Alrighty, let's get to some research tools here. 2 new R-bloggers posts. First from Absalon. You can share your Shiny expertise at ShinyConf 2025. The conference is April 9th. And I guess those are the workshops, and the main conference is the 10th and 11th. Now, submission deadline to take part is February 2nd. They're looking for workshops, Shiny app showcases, talks, things that will involve real-world case studies, advanced programming, enterprise development, whatever. So if you work with Shiny, this might be your thing. All right, then. Second research R-bloggers post is the return of the top 40 new CRAN packages. This is by Joseph Rickert. He went on hiatus for a while, but he's back for December 2024. And very exciting. This was one of my favorite blog series, so I'm glad to see it back. Some packages of note. There's actually a lot of them, and he breaks them out by category. There is, let's see if I can find the first one, is Onco datasets. Another one, and so that's a rich collection of data focused on cancer research. There's also TransPro-R, implementing tools for transcriptomic data analysis. There is Word Vector, which creates a dense vector representation of words and documents. There is Greta GAM, if I can find it, which implements a Greta Golding 2019 module that provides smoother functions for GAM models. So that's, I think, interesting there. And then finally, there's multi-var div, provides functions for the multivariate generalized Gaussian distribution. All right, and new CRAN packages from my own search of the newest packages for the last week. There is MEG-B, gradient boosting for longitudinal data, Smarter, a collection of modified R functions to make basic coding more convenient, and Phylospatial, spatial phylogenetic analyses. There are no new grants today, so I'll leave you for our time here. Astrophysical black hole with an extra shot of espresso. Thanks for joining me for Science Research Weekly. Science on.